Today's guest is going to tell you things you've never heard about before, and that just may change your life. Like, really. So, we're going to be speaking with Dr. Dayan Goodenowe, who is a researcher who dove into the world of plasmalogens, which he's going to explain to us in as simple terms as possible. We're going to learn from him how this molecule our body produces is just so vital to diseases of aging and how we can control them to keep our cholesterol levels healthy or lower our risk of heart disease and dementia and many other neurological diseases, even cancer. Dr. Goodnow started researching the biochemical mechanisms of disease in 1990. So he's got over 30 years of experience inventing cutting edge technology and creating medical grade supplements and identifying biochemical prodromes that are related to particular diseases that we women want to know more about. Now, keep in mind that Dr. Goodnow is a neuroscientist, not a medical doctor, and certainly not your doctor. And he's also the founder of Prodrome Sciences, the author of the book Breaking Alzheimer's, and creator of the drgoodnow.com website, where you can find everything about him, his research, and the things that we are going to cover today. So grab your notepad, because we are going to get a little geeky here, but try to keep the language for a fourth grader so we can all understand and learn. And before we start, let's read the fancy disclaimer. This content is for informational and educational purposes only. It's not intended to provide medical advice or to take the place of such advice or treatment from a personal physician. Any products and services are intended for research, educational, and informational use only and are not intended to diagnose or treat any disease. You should always seek the advice of a physician or other healthcare provider with any questions you have regarding the diagnosis, cure, treatment, mitigation, or prevention of any disease or other medical condition or impairment of status of your health. Neither Dr. Goodnow nor the publisher of this content takes responsibility for possible health consequences of any person or persons reading or following the information in this educational content. None of these statements in any of our materials has been evaluated by the FDA. While clinical applications may be shown, products and services are not validated for clinical use. So without further ado, let's meet Dr. Dayan Goodenowe. Welcome.
Well, thank you for having me. Nice to meet you, Zora.
So when researching your expertise and like scouring your website, there are several topics that pop up, which I know women in peri and postmenopause really want to know. And we won't have time to cover all the diseases, but I want to be sure to cover heart disease, clear the confusion on cholesterol, understand this link to the ApoE4 gene, like that's the Alzheimer's gene, and cover a little bit more on the brain health, like lowering our risk of dementia and other neurological problems. But in each sector, you talk about plasmalogens, and we need to first understand what this is and why it plays such a big role in all of these diseases. So what in the world is a plasmalogen?
So plasmalogens are a type of lipid. They're a fat, and they're part of the membrane structure of the human body. So when you look at human physiology, like sometimes we get stuck in the micro parts of health, right? People get focused on a small component and they lose track of the whole organism, which is really designed to work quite elegantly. And so your body has trillions of cells, like it's incredibly complex and distributed, right? There's a distribution of labor and resources across the human body, but all these cells are you. Like it's your same DNA in every single cell, whether it's your heart cell, your lung cell, your brain cell, right? So it's the same. And what's happened is these cells have adapted to a job that they're supposed to do in that particular region. It's like school teachers versus bus drivers versus neurosurgeons, right? They're still humans. They still have the same functional capability. And fundamentally, teachers can become neurosurgeons and neurosurgeons become teachers. But often if you grow up in a house of teachers, it's a higher probability that you'll become a teacher yourself. And so you kind of have that. So even though all humans have really the capacity to be all things, they don't really become all things because they can't be all things. And the human body's like that. And so a lot of times because remember, we start at a single cell. Like when we start from a single cell, the human body comes from, and that differentiation occurs. And so sometimes we think that's all programmed. And really what it is, it's adapting to a purpose. And each part of your body adjusts and optimizes for its job at hand. So if you're an accountant, you start to learn numbers better Okay. And so you're still human. Like everyone can run numbers if you try hard enough. And so that's how your human body is organized. But it's three-dimensional spheres and cubes. Like we're like a big, huge apartment complex with every single cell separated from each other. And we don't use bricks and mortar and plaster to separate. It's all biological, it's all living. And the material we use to create the walls that separate each of these cells are called phospholipids. And that's what the membranes separate. So phospholipids are kind of like a soap. They have a polar head group that likes to be in the water and a fat side that likes to be in the oil. So it's basically like creating your oil and vinegar dressing, so to speak, right? And so phospholipids are like that. And then they create what's called a bilayer. And so these two fatty ends connect to each other, and the polar ends and you end up with a biological wall. And so your body has these molecules that create this biological wall. And some walls are stiff and thick, some are thin and flexible, and they have different purposes. So plasmalogens are one of those molecules that your body uses to regulate the structure of all your membranes of the human body. And since you're such a complex of cells, that's actually a really big storage reservoir. So when people think about their omega-3s and even your estrogen and your fat cells and your adipose, like all that stuff, like that is stored in those membranes. That's fundamentally where this stuff is stored in the human body. And so plasmalogens are a critical component of that. And what's unique about plasmalogens is it's very much like cholesterol and hormones in a sense, is that the human body makes all of these things, right? We don't really have a dietary source. Like we don't put an essential estrogen in our milk for, you know what I mean? Like, so we don't, like, so your body makes these things on demand. It's not part of our diet supply. And plasmalogens are like that as well. The body makes them for on demand, and we make a lot of them. Like 20 to 30% of the entire brain fat of your brain is these plasmalogens. High levels in your heart, your lungs, your kidney. And so it has certain functions of the body, and it decreases with age. And it has large associations with certain diseases, Alzheimer's, big one there, like, but also all-cause mortality, heart disease, lung function, problems in childhood if there's children that are born with insufficiencies. Then later on in life, we get lots of inflammation, things like that can happen where our body is going through more of these faster than we're making them. And it's and then we get this depletion, and it has these negative consequences. So that's fundamentally what a plasmalogen is. And it has other functions like in cholesterol transport, and there's geeky things we can talk about, membrane fusion and how it works and why it affects certain parts of our life. But that's fundamentally what a plasmalogen is.
So the way I understand it, just to make sure I got it right, is you said it was a phospholipid, which makes part of a cell membrane. Is that correct? Yes. So wouldn't then but you also said that they regulate the membrane as well, or the function of the membrane. So so wouldn't plasmalogens be in every single cell?
Oh yeah, every single cell, and different types. So for example, the myelin. So your body, the wiring of your body, the neurological wiring of your body is very much like the wiring of your house. Like you have a wire that's in your wall, right? And it needs to go from point A to point B, and you don't have a bunch of sparks flying in your wall, otherwise you'd have a fire. So you have to have that, and that wire, that copper wire, has a protective coating around it. And that's in the human body, that protective coating is called myelin. And that's in our brain, or it's called white matter. And it's something that we developed very early in life. It's a very critical component, say, of autism, impaired myelin development. And it's a very big problem later on in life as our myelin starts getting depleted. So this protective coating. But so this membrane is a very tight, packed membrane. It looks basically like a plastic coating on a wire. It really does. That's what it looks like. And plasmalogens are like 70% of that. Very high amount. And it's the omega-9, the oleic acid version. And what's interesting about it is one of the only places on the planet you get this from is human breast milk. Okay, and why breastfeeding is critical for early childhood development is the plasmalogen precursor. So the developing child, for the last 8 weeks of pregnancy, the child gets a lot of plasmalogen through the placenta. And then for the first 6 months, for sure, a huge amount of this plasmalogen supply comes from human breast milk. And there's virtually none of it in cow's milk, for example. And so there's a big difference in terms of the different species, in terms of And then, we know all this stuff. We know anecdotally the difference between, not anecdotally, we know clinically the difference in childhood development from breastfed babies versus formula fed babies. And that is because of these plasmalogens that are in human breast milk. And so that omega-9, so what it does is it's what's required to create that nice tight packing. Now, on the exact opposite spectrum is your synapses of your brain. Okay, so you have this wire that goes through your wall, but then at some point in time, it has to hit your light bulb, right? At some point in time, when you flip the switch on your wall, okay, and you let electricity go through the wire, it has to escape the wire. Like the electricity has to go from the wire to the light bulb. Okay, and before there was no light, then there is light. So there has to be some system that connects one wire to another wire, right? And so that means that there's a connection plate, and in the human body, that connection plate is called a synapse. And we have that also in the heart for your sinus rhythms, and we have it in other places. But your neurological function and your neuromuscular function is this pulsing of neurotransmitters. Because again, everything that you can think of in your regular life that makes sense, in your house and in your car and whatever, your body does all these same things. It just uses biological material to do all these things that we think commonly about it. And it follows the same rules. In fact, it's the opposite way around. We've built things in our world just because they make logical sense. So there's logical patterns in the things that we do. Anyway, so that how two living cells communicate with each other is they basically spit out neurotransmitters. And it's like having a shower head and you're just pulsing. If you turn the water on and off, on and off, on and off, it's just like this pulsing. That's what happens. But that physically, that membrane has to open up and release neurotransmitters and then close up again. So it's a very, very dynamic process. And so that can't be material like the coating on a wire. Like that doesn't work, right? Because it's really stiff. It's designed not to let anything out. And so at the synapse level, you have these omega-3 plasmalogens. Okay, so people talk about fish oils, the DHA. That's one of the components of why these different fatty acids in our diet have different membrane modulation. So again, still a phospholipid bilayer, still phospholipids, but it's different phospholipids. So now you have this membrane that's really loosey-goosey, and it'll open up and close. And in order for it to do its job properly, it has to have a high amounts of these omega-3 plasmalogens, specifically DHA. And that's what's related to cognitive functioning in the elderly, in our brain. It's related to our neuromuscular function when we're younger, especially for heart function. And so the omega-3 plasmalogen is a critical component of that performance capability of the body.
I'm a little confused. So you said that there's the omega-3 plasmalogen, specifically DHA. So that then tells me that there are many different types of plasmalogens. What is the difference between omega-3 fatty acid and a plasmalogen? And what is an omega-3 plasmalogen?
So yeah, so when we talk about omega-3 and omega-9 and omega-6, those are fatty acids. Okay, they're not actually, the plasmalogen is this backbone. So your phospholipids, so the fat, for example, you go to your cupboard and you look for olive oil, right? Olive oil is a triglyceride. And when you get a blood test, you're looking for your total triglycerides. And the stuff that's actually in your fat cells, those are triglycerides. They're basically the same thing that's in your cupboard, and it's a food supply. So a triglyceride means three, means it has 3 fatty acids attached to a glycerol backbone. So it's basically like you can imagine a fork with 3 noodles hanging off of it. That's basically what a triglyceride looks like. And now you have, if it's olive oil, what you have is you have omega-9 fatty acids on it. So you have these 3 oleic acids, okay? And if it's, say, corn oil or sunflower oil or whatever it is, normally it's omega-6, or soy oil, that'll have the linoleic acid, but it's still the glycerol backbone. But what's changed now is what the type of noodles that are hanging off the fork. And so if it's omega-9, which we think is very healthy for heart function and the Mediterranean diet and all that kind of stuff, and then you have this pro-inflammatory omega-6, which is your linoleic acid, and then you have omega-3s, which is your DHAs, and they have different lengths. And so what happens then is when they stack together, right, they create different, because the membrane is millions and millions of these things stacked up. So if you think about when you're doing construction in your house, for example, if you buy a pallet full of plywood, right? And you've got 50 slides of plywood. They'll stack on top of each other, and they'll just seal right up to each other. Like, in fact, you have a hard time pulling one piece of plywood off another piece of plywood. That's what omega-9 plasmalogens do. They stack really nice and tight. Whereas an omega-3 is all kinky. It's like stacking up a chain link fence, right? It never really stacks properly. It's like you're trying to stack these things, but they're not stacking properly. But that also allows you to move them in and out, and it's easy to pick up one sheet and pull it around, and it's flexible. So when you have an omega-3, like a DHA, they're called what's polyunsaturated, and this unsaturation creates these kinks in it, and it makes them less plywood flat-like. And that's kind of how your body can use different amounts. So depending on how much DHA you have in your membrane versus how much omega-9, you can have a really thick, tight membrane, or you can have a loose membrane. And your body, and that's why your nutrition has to allow your body to make what it needs, right? So if it wants a chain link fence, it needs to have the ability to make a chain link fence. When it wants to make a wall, you don't want to use a chain link fence to build a wall in your house. It won't keep too much wind out of your house. So you want to put a plywood and so that's how your body makes things. It's really the same. And so it has different types of building material for different things. And then what happens when we get older, or we become deficient in things, or we have too much of one thing, for example, I tell people, it's like you're making your favorite Thanksgiving cake, if you will, right? And you got all these ingredients, 10 ingredients, and you can have everything you want, but if you only have half the flour, you're only making half a cake, right? So you can't, and that's what we call the rate limiting component of something. So there's certain things that we become deficient in, or we don't get enough of. And if you don't have enough of it, your body will make you can have all the ingredients you like, but if you're missing a certain ingredient, it'll only make as much as that ingredient. And that's considered a rate limiting ingredient. So that's kind of what happens as we get older and we start losing things and we start having loss of function. 99.9% of the time, it's really because we have a deficiency in something. It's very rare that we have, and usually the excesses that we have are the result of a deficiency. Okay, so it's so you have a deficiency and it creates an excess somewhere else, and so it's kind of sometimes it gets trickery on that part.
So the way you explain it, there's the different omegas, and some are loose, give us loose membranes, or some are tight junctions, and it sounds like they're both very important. It's not like
right, and those are just fatty acids. Those are just fatty acids in the food supply. Okay, but what's important is what they're attached to. Okay, so you have these different types of phospholipids. So now you have phosphocholines, and you'll have ethanolamines, and you have plasmalogens. So it's the fatty acids are just a building block of it. It's not, so DHA is not a phospholipid. It's just a fatty acid, and if it's on a triglycerol, if it's on a glycerol backbone, it's oil, right? And if it's on a phospholipid backbone, then it's a phospholipid. So that's all.
So then when you say omega-3 plasmalogen, then that means the part of the cell membrane, or the phospholipid of a fatty acid. Is that correct?
Yeah, it means the fatty acid. You can think of a fatty acid like the color of a car. The car is a car, whether it's blue or red or yellow. Okay, the color of the car doesn't change the car. Okay, fatty acids like omega-3, that's red, yellow, blue. Okay, so you can have the same car with 3 different colors, and so the color doesn't make the car. The color is just it defines what type of car it is. But so that's really the fatty acids are just a piece of the phospholipid. They are not the phospholipid, and it changes what the phospholipid does.
So then, but like we said, every cell has should have phospholipids.
Oh yeah, lots of.
Some have more, yeah, some have less. As I picked up that as we age, we lose the plasmalogen, or the plasmalogen function. I'm not sure if it's number or quantity or quality, but what's happening to the plasmalogens from birth until death?
Yeah, so what happens then, so think about it, when a grape turns into a raisin, right? It becomes dehydrated. And because what creates the plumpness a grape is the water content of the grape. Okay, and when you lose the water content, it shrinks into a raisin. Human body is fundamentally made of fat. Okay, your membranes are fat. Your supple skin, fat. Okay, your brain is fat. So when you shrink as you get older, when you shrivel up, okay, and your brain shrinks, it's not losing water, it's losing fat. Okay, and it's fundamentally losing these plasmalogens, and that's the big, so if you want a full brain, you need a full level of plasmalogens. Okay, and your brain will shrink as you stop being able to make enough of them, because it's a critical component of all these membranes. And so that's how the difference in our human physiology goes forward on the core structure. So plasmalogens and this membrane structure is one of the key components of overall human physiology. And then we talk about mitochondrial strength and all this other stuff, but that's one of the core components. So as we get older, like we brain myelinate. So this process of learning and retaining, and people talk about brain fog, and they get into postmenopausal or premenopausal, they can't think straight and all this kind of stuff. Our ability to learn is part of the myelination process. Okay, and it's ability for us to tune in to something. So learning is adaptation. Learning is having a conversation and saying, did I have a good response? Did that make the person I'm talking to happy, or did it make them angry? No, did I want to make them happy, or did I want to make them angry? So if I want to make them angry, I'm going to do that again. If I want to make them happy, I'm going to do this again. So, but then it's that feedback loop, and then you learn, and that creates a memory. Okay, and that is your myelination process. That's the wiring. That's that white matter, and that's why we have these deficiencies in learning in autistic children, and even when you talk about general cognitive issues with, say, women with MS, right, that happen in that age group. It's when that white matter myelination comes weak, because what the wiring of your brain does, it creates precision. So think if you go into a crowded room of people, right, there could be a big wedding reception, and there could be 10 conversations going on in the room. And the fact that you can stand and you can kind of tune into one conversation after another, that ability, like one of the critical components of human physiology, is our ability to isolate one signal from another signal. And it's tuning out the noise. Okay, so most neurological diseases comes from a lack of being able to tune out the noise. All the noise starts coming in, and I get overwhelmed with them. I can't filter it out. And so when you move from one conversation to another, it's not that you're listening to the conversation, it's that you're tuning out all the other conversations. And then you start listening to a conversation of 10 people talking. And what happens then is if one person starts yelling in that conversation, you want to be able to hear that one person yell, and the other 9 people is fine. When your myelination gets bad, when one person yells, you can't differentiate between the other 9. And it sounds like all 10 of them are yelling at you. And that's fundamentally autism for you right there. But we do the same thing as we get older, is we have an inability to deal with this adaptation of all the stimuli in our life. And we become more rigid in our ways. We create patterns in our world that we reduce this type of extraneous stimuli, because we have less and less ability to handle that. And this can be transient. Like you can just have a bad day and you say, please don't anyone talk to me. I don't want to hear a single sound today, right? That's can be a transient thing, and you might feel better the next day. And then it can happen for long periods of time as you get chronically into, as we get older and people get demented, and what we call dementia, or just brain fog, all that kind of stuff has the same process. So anyways, I'm babbling. So that's how things work. And they're designed to work in certain ways. And then there's our biochemistry supports that. It's really not magic. It's actually quite logical, and it's really, people just don't usually think of it in that type of format.
So yeah, what I'm hearing is that, we are adaptable, and as we age, these things happen, you say. Why? And what does that have to do with plasmalogens?
Well, so plasmalogens, that's just becomes like menopause. Your body isn't trained or adapted to live that much longer. Okay, so there's no selection process for living to 300 years of age, right? Like you have a purpose. The body has a distribution of labor, right? We have, boys get testosterone, girls get estradiol, okay, the female body has a purpose physiologically, okay, and its purpose is to bear children, and then has a window of time, and it's adapted to that role, right? The male role has its purpose. It has better strength. It has other capabilities that give it the things that traditionally a male body can perform. They're stronger, and they can hunt, and they can do all the things that we do, and that those are complementary to each other, right? And so both males and females, and there's a window of time where that separation of labor is very, very important. It's less so as our society gets more and more sophisticated, and it becomes the differentiating purposes of the male sex versus the female sex becomes blurred, right? But that doesn't change the fact that we still have that biological purpose. And that's really the critical component, is purpose. Like, you have to have a purpose. And one of the things that we have when we get older, we set deadlines, and you should never, ever set a deadline. You should set milestones. Okay. Like, there's no such thing as anti-aging. You just can direct your aging. Okay. You're going to age. But the thing is, you continue to age. And the question is you have to create new purposes in your life. You can't have a deadline. You can have a milestone. And this is where I tell people, retirement is basically the acceptance of death, because it says, you know what, I'm not useful anymore. And people think about all these stressful things in their early life. They're planning their home, they're planning their relationships, they're planning their family, they're planning a whole bunch of things. Their brain is, what am I going to be doing over this process, right? And sometimes you'll create this hard line. Okay, I'm gonna work my butt off, and then I'm going to stop when I'm 50 or whatever it is, right? Which is really kind of, it sounds like an idea when you're young, but later on you realize, well, I'm not done yet. I got other things I want to do in my life. And so you have to kind of, and if you don't have a purpose, you have to make one up, because if you don't have a reason to live, you won't live. That's it. It's just a matter of palliative care now. You're just basically putting in time till death. So plasmalogens, hormone therapies, nutrition, exercise, these are things that you do now to trick your body or train your body to say, hey, you have a purpose still. You still have to get up. You still need muscle tone. You still need energy. You still need the biochemical capability to do these things, because you're not done yet. And because your body is what you physically do, but it's also what you internally do. I can take the most athletic football player on the planet, okay, and if I put them on a couch for 6 months, okay, they're not going to look the same. Okay, that he will adapt to the couch. Okay, the couch, and so your body will adapt to the environment you put it into. And so the most powerful thing that we all have to do in our life as we get older is realize that, once certain phases of our life happen, we have to create new purposes. Because if you don't, you have to, and then you have to have a reason to then create the health to achieve that purpose. And this is when I'm talking about the biochemistry, and we talk about cholesterol and hormones and plasmalogens and mitochondrial function, this is now saying, okay, if I'm going to take a car from New York to LA, well, I'm going to get it checked out first. Okay, I'm going to put tires on it. I'm going to make sure it's going to run me. I might be, if I'm only going to drive it back and forth from the market, then I don't really care too much, because if it breaks down, I'm just going to walk. But if you got a plan for the next 50 years of your life, well, then you got to make a plan for that. You got to have a body that can get you through there. You got to have a brain that'll get you through there. And then you have to say, okay, what does that body, what does that brain need to achieve that purpose, right? Because if you have, and we unconsciously create those purposes in life, and the world around us forces it on us, right? And then we get better. We just, with time, you save some money, you pay your house, you get this and that, and now all that stress is diminished, but you now have to replace that with something else. Okay, you have to replace that drive, because if you don't, you just atrophy. You become that football player that's sitting on a couch, and you will adapt to death. So death is an adaptation. Okay, we teach ourselves to die. That's how we die. We teach our bodies to die, and it learns from us, and it learns quite well, and it successfully, plays out our teachings until we're dead. And that's kind of where I look at things differently. The human physiology has a purpose. Your body's supposed to work, and we know how it works, and we actually know what health is. We actually know what health is very, very accurately, and all we have to do is we have to measure deviations from health. We live in a world where people focus on disease, okay? Because you don't see your doctor until you're sick. You don't see, and that's really a backwards way of thinking. It's like saying, I'm not going to check the oil in my car until my engine stops running. Then I'm going to bring it to them, and they can tell me if the engine's out of oil or not. Well, that's just stupid, right? You know how much oil is supposed to be in the car. I don't need to wait for it to break down to keep it full. Plasmalogens are one of those things. You don't have to wait for the negative consequences of low plasmalogens. Like, we know that's not a good thing. You want those up front. And then other aspects of life as we get older, inflammation, the core components of aging, the skeletal muscle mass. Like, for women, that's one of the most critical things in life, especially post-menopausal, premenopausal. Like, estrogen, the receptors are in your skeletal muscle, and your body has been used to it. And estrogen is such a powerful neuroprotectant. It's what protects girls from autism. And then what later on, it's what is reason why women get MS at higher rates than men. And so, but your body is used to that. And so when you remove it, there's a change in adaptation. And that's why all these things change in life. And that's why we see this kind of, androgenization of both males and females as we get older. We both become less male and less female. So
I have a question. So you said that the body is adapting. The body is made to adapt, either adapt to the couch and death, or adapting to, say, exercise and a stressor, and then has a purpose in life. This is the things that I'm hearing. And when you say that the women who are going through menopause, perimenopause, we're losing our estrogen. So I'm guessing we're adapting, but probably in a negative way. Or why wouldn't the body, if this is a natural thing and it happens, no matter how healthy you are, you can be the biggest biohacker in the world, you're going to go through menopause. There's nothing, it seems, that we can do to stop that natural loss of hormones. We can top them up, we can take hormone therapy, and we can bring exogenous things into our life to try to have a good experience through menopause. And of course, then perhaps lower our risk of osteoporosis or other things happening. So why aren't we adapting? If this is such a natural thing, why do our bodies adapting in a positive way? And maybe there is a positive way. I'm just being negative and looking at
no, there's no positive way. It's just atrophy. It's just, quite frankly, apathy. Okay, really, the body, it doesn't think that way. Like, it doesn't have, there's, first of all, there's no off switch. Okay, you don't go to bed and turn off. Your heart's still pumping. Your lungs are still breathing. You're still bringing in oxygen from the atmosphere, and you're converting it to water. Okay, and you're expelling carbon dioxide. The human body never ever turns off. Okay, you are a perpetual motion machine. So you don't have the ability to say no. Okay, all you have the ability to say is what. Okay, what am I going to do with this body? Okay, because it doesn't stop. Okay, so you have the power to choosing what direction it goes in. You can't stop it from moving. Okay, there's no way the human body can be stopped. If it only stops when you die. So people, this idea of anti-aging or reversing aging, like, that is just logically stupid. It's just not possible, because you can't go backwards. You can change the direction. So
you can reverse your biological age, or you can reverse osteoporosis, or you can reverse, there's certain things you can reverse, right?
No, there's no reversing of anything. Like, you can go back, you can continue backwards. Like, you're not retracing your steps. Like, you're not walking in the snow and putting your footsteps in the snow, and then you're not going backwards and putting your feet back in the same steps. If you're reversing aging, you're turning around and you're walking on the snow next to your other path. Okay, so you're still moving in a direction. You're just moving in a direction that is more youth-like, right? And so this biological age, and you talk about your epigenetics and methylation pathways and all that kind of stuff. This happens after the fact. They don't make you young. They are a reflection of your youth. Okay, and a reflection of the capacity that you've trained your body to do. Okay, so when you get older, what happens is you work out less. Okay, your body uses less energy. And so it's not going to waste energy. It's going to adapt to the energy demands that you have put upon it. And one of the ways it prevents you from blowing up is the epigenetics. Okay, and so it'll start turning things off, okay, or toning things down that you're not using. It's going to, if you have less need for mitochondrial function, your body will make less mitochondrial function. And so the reason why we work out, like if you go to the gym and you work out weights, okay, that's to trick your body to say, you know what, I am living in a world where I need to lift 40 pounds every day. Okay. Even though you don't really have to lift 40 pounds. Like I'm just moving my mouse around. I need to lift 1 pound, but the body's not smart enough for that. So you trick it and you say, no, I'm going to train my body so that it has capacity. And then when I'm not using that capacity, I've created that function. So for instance, all of type 2 diabetes in people is fundamentally related to loss of muscle mass. Okay. And all the cancers are related to this situation as well. And you can quickly look at, of all the cells of your body, you can ask the question, what parts of the human body never ever get cancer? Okay. People don't ask these questions. You never get cancer. It's almost unheard of to ever see cancer of the heart, for example, or cancer of the muscle. So your skeletal muscles virtually never, ever, ever become cancerous. Even metastatic cancers, like only in extremely rare circumstances that you'll actually have metastasis to an actual muscle. And that's because those muscles they're in a fasting state. They use fat for energy. And so what happens when we get older, if we start losing our skeletal muscle mass, this balance between using fatty acid for energy, which is from your adipose tissue, okay, and fat, and to glucose metabolism, and that balance gets out of whack. And so now you become insulin insensitive because the body now is saying, hey, I can't process all this fatty acids that are coming out of my fat cells. Your triglyceride levels elevate in your blood, and your body starts recycling fat. Okay, your fat cells are sending energy out. Basically, it's going to your cupboards, getting olive oil, right? Like that's what you have. You have olive oil sitting in your fat. Okay, and his body says, "Hey, time for some energy," so it sends olive oil out of your fat cells to all your cells of your body. And the body, if the body doesn't, it's supposed to have a certain amount of that energy and certain amount, and that's your fasting energy. And if it can't process that, it sends it back to your fat cells. So when your triglycerides get elevated in your blood, you're recycling fat. So you fundamentally can't lose weight if you get your triglyceride levels over 100, like, obviously within reason, because all you're doing is your fat cells are sending fat to your body to use it up, and your body says, I can't use all this crap, put it back in the cupboard. So you're basically taking it out and putting it back, taking it out, putting it back all day long. And so this is what happens with cancer. Cancer happens from a lack of a fasting state. So the BRCA genotype for breast cancer, the BRCA and ovarian cancer, these are very clearly articulated. We can diagnose this long in advance for women. So this is why the body is designed to work in a certain functional way. So that's kind of this reversing aging really isn't about reversing aging. It's about continuing on to a healthier, younger state. Okay, you're not going backwards, you're going towards a healthier, younger state. Okay, you're not going back to your previous healthy state. Okay, you're going to a future, younger, healthy state. And it's really important that people understand the directionality of that, because then you can get off track. You can have a bad year or two, and say, holy crap, I'm not healthy right now. So when you go from an unhealthy state to a healthy state, it's a positive pathway it's moving forward. You never ever move back. There's no such thing as going back.
I like how you put it. You're moving forward to you said you're moving forward to a youthful state, but yeah, not backward. I have to go back and remember what you said exactly, but it was really better than the word anti-aging. I certainly liked it much better, because it's not like most of the women I speak to in their 50s or 60s, they don't want to go back to their 20s, but they do want to be the best version of themselves. They would like to feel, have that energy of a 20-year-old, or they would have, but not being 20 again. So that makes perfect sense. But I want to go to the plasmalogens again, because you mentioned that sort of testing your hormones and testing your cholesterol, testing plasmalogens and knowing your levels. Why aren't doctors testing our plasmalogens if they're so important?
Well, most of them don't know about this, right? Again, a lot of the diseases and death of aging are just recently being dealt with. Like we're trying to use acute care medicine. We have this to deal with chronic health conditions, okay? And one of the biggest philosophies that you have to get out of your head is that the absence of disease is health. Okay, we live in a world that says, you know what? If I just take away all the bad stuff in your world, you're miraculously going to be great. That's not true. Okay, I can, you know, I can take away your heart cancer, your heart disease risk, and I can take away, you know, I can try to remove the symptoms of that, but removing the symptoms of a negative does not create a positive. And so this concept of that's the first thing people have to realize. And what we've done is we said, oh, you know what? Here's a biomarker. Glucose is high. You have type 2 diabetes. If I just lower glucose with insulin, you're going to have some miraculous recovery. Just not true. Okay, we're thinking about these things. It might prevent you from dying in the next, you know, year, but it doesn't improve your long-term prospects. And so now when you start looking at longevity and vitality through an indefinite lifespan, right? Because there really, and I truly believe that there really is no upper limit to human lifespan. Okay, the human body is a functional, physiological. There's no programmed. Okay, we just don't know how to maintain all the things that we need to maintain. So that's why doctors don't really understand plasmalogens. It hasn't been, we've known about them since the 20s. We know rare diseases in children. If you're deficient in plasmalogens, you don't live. You barely get out of the womb. You're dead. Okay, so we know the critical component of it in human physiology. So, but really down to the brass tacks, why plasmalogen is so critical. We're talking a 30-year lifespan differential. Okay, so a 65-year-old person, man or female, with low plasmalogens has the same life expectancy as a 95-year-old with high plasmalogens. It's a 30-year differential in lifespan, okay? Low levels of the DHA plasmalogen specifically are one of the, probably the major risk factor for breast cancer, okay, and ovarian cancer. Those things will, you know, and when we talk about cancer risk, people should realize that there's a difference between having the propensity to have a disease versus having a disease. Okay, so, and it's really the bald tire, flat tire analogy, right? You can have a bald tire on your car and doesn't necessarily mean you're going to get a flat tomorrow. But it means that you have, if the right circumstances arise, you're more likely to get a flat tire than someone who has a brand new tire, okay? And so how we do this statistically and scientifically is if I go to a tire shop and I look at all the tires that are flat, and, you know, all this, if I go to the back of the damn thing and say, look at all these tires, and I'm going to measure the tread depth on all the flat tires, you'll find that 90% of the flat tires have bald. Now, there'll be a few brand new tires in there that just ran over some, you know, anti-speedaway spike or something like that, but a very small percentage of those will do that, right? That's when we're dealing with it. So when we're doing what we do with prodromes, which is the, you know, prodrome means that which comes before, is ask the question is, what are the prodromes to disease before you get them? And then you have to have, so you can have a bald tire and you might get lucky. You might be able to drive on smooth streets and that bald tire might last you long and you might die of might hit a telephone post. And so the bald tire never ever turned out to be a bad thing in your life. It just was, well, I had that thing and it never really turned into reality. It was just this lurking risk. If I found something in my life that was the nail, it would happen. That's what happens with cancers, breast cancer, ovarian cancer. So we can diagnose with almost perfect accuracy all women who will get ovarian cancer, okay? But more importantly, we can tell all women who won't, right? So you can, like if you talk about the BRCA genotype and the relative risk ratios of that, it's about saying, okay, here is someone who has a biochemical bald tire, and you might make it, you might not. Something else might get you. Plasmalogens are like that. Low plasmalogens is running around on a bald tire, waiting for some adverse event to hit you, and then you're not able to handle it. Okay. And then all of a sudden you get underwater and you can't catch up again. And so that's one of the critical components of these plasmalogens in cancers and in Alzheimer's disease. And as we get older, we lose these things, and we lose them in relationship to our loss of skeletal muscle mass. Like all the things that are healthy in your world, you want low triglycerides, you want good HDL levels, you want good skeletal muscle mass, all those things. The reason why we say eat and exercise, and mostly, especially for women and men in the elderly age groups like us, is it's resistance training. It's really the resistance training component. It's building skeletal muscle mass. Those are little filters in your blood and your body that keep you young. It's the most important thing to do. So anyway, so that's kind of where, and so plasmalogens are built, that supports it, and also supports your hormone functions. That's why you go through menopause better if you have, skeletal muscle mass and things like that, because your body can make the cholesterol, which helps maintain your steroid manufacturing in all your cells.
Okay, I want to go through the cholesterol. That's got to talk about that. But
right.
Just one quick question, maybe quick answer. So would exercise increase our plasmalogens? Like I'm talking about strength training, exercise increase plasmalogens?
Yeah, absolutely. Because it increases your peroxisomal function. So getting into the geeky space. So when you deal with fasting, fat metabolism, okay, your body has two gears. I tell people the only reason you eat is to put fuel in your fat cells. Okay. It's like your car has a gas tank. Okay. You don't drive around town with the hose next to the pump driving around with you. No, you fill up the gas tank, you drive around till the gas tank's empty, then you fill the gas tank back up again. Okay. Eating is filling up the gas tank. Okay. That's the fed state. That's when we've eaten a meal. The fat in your fat cells, that is the gas tank. Okay. And so your body, the reason why we eat is because we have to have this cyclic storage of energy, and then we use that stored energy. And so this keto diet people talk about, or this intermittent fasting or restricted time eating, those are all really important. For women, the long fasting is not as important as men, I think, but it's the type of food you eat at different types of time of day. So you want that low glycemic foods in the mornings and the evenings, and have a nice, good, full meal once. And it's about creating one insulin spike, and that's that fed state. Okay, your body is fed and it's storing its energy for later. Then it switches to the fasting state. And every single cancer, don't care if it's colon cancer, pancreatic cancer, breast cancer, ovarian cancer, all cancers are related to the inability to maintain that fasting state. All cancers are related to cholesterol dysregulation. Period. Full stop. And I do very large lectures, thousands and thousands of patients on this studies. And so that's why resistance training, building that muscle mass up, it maintains that glucose fat balance. And fundamentally, if you're physically fit, you cannot get type 2 diabetes unless you've got some sort of really severe, issue in, some toxicity or something like that.
Interesting. So let's talk about women going through peri and post-menopause and elevated cholesterol levels, because I understand plasmalogens play some kind of a role in our cholesterol levels. And you mentioned in other podcasts that I've listened to, think about the ApoE4 gene as well. So we want to talk a little bit about the heart and the brain health for women going through this transition. Should a woman be worried about elevated cholesterols, and then what is considered elevated, or what is a safe or optimized cholesterol level, and what do we do about it?
Yeah, so the optimal cholesterol levels going forward is around 240. Okay, that's people with a cholesterol level around 240 in the US scale is they live the longest. And
that's
really
not what our doctor says. They say get under 200.
Yeah, but that's just, as soon as cholesterol level gets below 200, your all-cause mortality doubles. And that's not guesswork. That is 164 countries, tens of millions of patients. This is not up for question. So as soon as cholesterol gets under 200, all-cause mortality starts doubling. And
then why do the doctors want us to get it under 200?
My little quip on that is it's from cardiologists. What they're interested in is they want to make sure that you die of anything but cardiovascular disease or heart disease. So the reason why people this is a cholesterol story with statins, and reason why they were created in the first place is that oxidized LDL is related to atherosclerosis. Okay, so your cholesterol is transported in your blood on protein particles called lipoproteins. So you have LDL cholesterol, HDL cholesterol. These things have two different purposes. One sends cholesterol to your cells, which is your LDL. That's your cholesterol feeding system. And cholesterol, just be very clear, it's probably the most critical human molecule. Okay, we get very little of it. We get a very small percentage of it from animal food products. We get virtually none of it in the plant world. The human body makes its own cholesterol, just like plasmalogens, and it is critical. It's a critical component of all of our membranes. All of your steroids, all of your hormones come from cholesterol. Period. It's like 36 steps to make it. It's one of the most, and once you make it, it's like titanium. Your body holds on to it because it's so critically powerful. And so all your cells make their own cholesterol. And there's also a distribution system, this LDL system that sends it out to your cells. And then when your cells make enough cholesterol, it's like imagine having solar panels on your house. So at some point you're making enough energy for your house, but if you make more than your house needs, you put energy back into the grid. Okay, and you donate energy. The donation of energy, which is a donation of cholesterol, is your HDL system. That's saying, I've got super healthy cells. I'm full, I'm happy. I'm going to share my cholesterol with the rest of the cells. Okay, that's why high HDL is such a powerful, good predictor. Low HDL, so low HDL, low phosphocholine, one of the key determiners of all cancer rates, for example. Like this is really well established. Like there's so many research on this. So what does it mean when you have cholesterol levels below 200? That means your cells are sick, fundamentally. It means the cells can't make enough of their own cholesterol. And so they have to they're sucking cholesterol out of the blood supply. So the LDL cholesterol, which is the bulk of your cholesterol in your blood, it goes into your cells. HDL cholesterol doesn't go into your cells. So why this whole thing about statins and cardiovascular disease? Well, what happens is this circulating cholesterol, if you have oxidative stress in your body, okay, if your body is inflamed, this cholesterol in your blood will get oxidized. It's called oxidized LDL. And that is pro-inflammatory. It'll go into your veins, like the inner lining of your I'm losing my mind right now. Arteries in your vessels, the endothelial layers, and it creates what these call foamy macrophages, and it spreads out. And so what happens is when you take a statin, what statins do is they block the cells of your body from making their own cholesterol. And it forces, so since the cell can't make its own cholesterol, it has to pull all the cholesterol demand from the blood supply. And so that's why statins lower LDL cholesterol. And what it does is any oxidized LDL that's in your blood, instead of going into your heart and the endothelial layers, it gets sucked into your cells, metabolize it. So what it does is it pulls oxidized LDL. And this is very large studies. Big New England Journal of Medicine paper basically says that there is no cardiovascular benefit of statins in anyone with low C-reactive protein levels. So if you don't have oxidative stress in your body, okay, there is no benefit of a statin. But if you are inflamed, you have high C-reactive protein levels, then the statin it's basically, it just pulls all the bad cholesterol, the oxidized cholesterol, out of your blood supply and gets the rest of your body to start metabolizing it out of the system.
So it sounds like the important factor here is if the cholesterol is oxidized or not.
Correct.
Okay.
And so cholesterol itself is very benign. So, and only the all-cause mortality for cholesterol doesn't really start to go up until around 300. And it's usually not, at that point, it's not really due to the cholesterol itself. It's an indicator of other issues of, cellular failure or liver failure and stuff like that.
So if I understood correctly, then you said optimal cholesterol levels for women going through peri or postmenopause, or maybe perhaps people in general, I'm not sure.
All time.
Is 249 or somewhere around the 250 mark.
Yeah, I try to tell people, say between 220 and 250, that is your optimal level. And then your HDL levels, you want to be in that 60 to 70 range. Now, females, men, if they get really super high levels, they can have a bit of a risk. Females can have very high levels of HDL with no increased risk. And so that's the benefit. And that curvature, and the older you get, the higher the cholesterol is to your benefit. Interesting.
Oh, interesting. So as we get into our 60s, 70s, 80s, then that optimal range goes up from, I don't know, 220 to 230.
Exactly. In a small, but fundamentally your entire life. Like when I look at kids and people have these early disease issues, often they'll have low cholesterol levels. If you compare North America to Japan, for example, on average, if I take 1,000 people and I got 50 some thousand or almost 100,000 blood samples in my freezers, on average, the cholesterol levels in the Japanese population are about 20 units higher than they are in North America. Okay, right. And just across the board, if I just randomly take 1,000 Japanese people at all age groups and 1,000 North Americans, you'll see that the cholesterol levels in Japan are almost 20 units higher on average across the board, male and female.
Are they also trying to lower it, or they have the same indoctrination with the cardiologists, or are they?
Not so much. Not so much. There'll still be a bit of it, but not so much. No, it'd be very much less statin usage.
So
okay, that's why cholesterol is so important.
If I heard you correctly, then you said also if it's too low, it's dangerous. If it's too high, saying over 300, that's also a marker of something's not quite right in your body, and you should take a look at it. Is that correct?
Yeah, your body's making too much for some reason. It's got some sort of overproduction going on for some reason, and you'd have to look into a little more deeper into that. And then that goes into this ApoE4 genotype thing that you wanted to talk about, right? And risk of Alzheimer's disease. So ApoE4, so remember I talked to you about this apartment complex where every cell has its outer walls. Huge amount, almost 50% of those outer cell walls are cholesterol. So when we do a blood test, you're only measuring a small part of cholesterol. You're actually measuring this esterified cholesterol on lipoproteins. 85% of the human cholesterol in your body, you're not looking at. It's in the membranes and it's in the free form. And that's really where it drives your cellular activity and in the brain. And so ApoE, okay, so you have these different lipoproteins. Okay, Apoe is your HDL. Apob is your LDL. Apoe is ambidextrous. Apoe can act as an LDL particle or as an HDL particle. It can do both things. So Apob, LDL, okay, it can't transport cholesterol out of your cells. It can't do reverse cholesterol transport, but it goes into your cells through the LDL receptor. HDL, it cannot get into your cells. Okay, it can't get into the cells of your body. It only does the transport. Apoe is unique because it can go both. It can act as LDL. It can send cholesterol into your cells, and it can do reverse cholesterol transport simultaneously. It has both functionalities, but it's very small in the periphery. It's almost exclusively all the cholesterol proteins in your brain are almost all Apoe. Okay, and so your brain uses, and so your brain is like Chinatown. Like it's a whole bunch of little streets and it's complicated and no one's going far distances, right? The rest of your body is the interstate highway system. Okay, we're moving things from Chicago to New York and big, long transport systems, right? The brain isn't like that. And so instead of using these big, semi-transport trailers, it uses much smaller particles that can get in and out of the places, and it uses Apoe for that. And so Apoe has these different genotypes. There's the E2, there's the E3, there's the E4. And the difference between these is only related to this HDL type function of Apoe, this cholesterol sharing part. So the ApoE4 carriers, they're cholesterol savers. Okay, so when the cell makes cholesterol, it kind of holds on to a bit more. Says, I don't really like sharing. Okay, and for most of our life, that's actually healthy. It makes robust cells, bacterial susceptibility. So ApoE4 carriers have certain levels of higher resilience than non-E4 carriers. That's why we still have it in our gene pool. But the counter veiling. So, the ApoE4 and 3 and 2 is kind of a Goldilocks situation, right? There's, what's the right happy medium one? And the second partner in this three-legged race is your plasmalogens. Okay, so your plasmalogen levels in your membrane also drive your cholesterol transport. So when we're young, no problem with E4. Okay, and as we get older and our plasmalogens start going down, then all of a sudden the ApoE partner, the other person in the three-legged race, is no longer carrying their own weight anymore. Okay, so all of a sudden now this balance is out of whack. And that's why the plasmalogens neutralize the E4 genotype. So people with an E4 genotype that have normal or high plasmalogen levels have no increased risk of Alzheimer's disease. Okay, so you can neutralize, and this is the other part with genetic diseases. When people think about the BRCA genotype, you can neutralize these risk factors because they're not magic. They have a mechanism, and your body, if you're alive, okay, your body can deal with it. Like if BRCA was so bad, you wouldn't make it out of the uterus. Okay, you would die before you're born if it was such a critical mutation that your body. So clearly, the human body can survive with the BRCA genotype, right? So it has mechanisms to deal with that. And it's your job as the conservator of your genotype to create an environment that is consistent with your genotype. Okay, you don't want to fight your genotype. Fighting your genotype is just self-hate. Like that is you. It's who you are. Like it's your job to say, hey, I'm an E4 carrier. I need to make sure this is what I have in my lifestyle because that's my. And then blood testing helps us to have that communication link. The body communicates to us. That's the language it talks to us, right? It's telling us what we like. We measure our blood levels, our cholesterol, our glucose, and our, homocysteines and uric acids, and all these different biomarkers in the blood. That's a language. That's a conversation. That's your body saying, "Hey, here's how I'm doing." It's basically telling you what to go shopping for at the grocery store. This is what I need. This is what I don't need, and it's a communication. So that's where understanding your blood work is a critical component of basically learning how to talk to your body or listen. It's not really talk; it's a listening process. And so that's the ApoE4 process. So that's why the E4 genotype. What happens is that when the plasmalogen levels in the membrane go down, the cholesterol doesn't get transported out, and so the cholesterol in the membranes builds up. And so E4 carrier, and then when that happens, the membranes get too stiff, and parts of the function of the membranes stop working properly, and then you have all these cascading effects. The amyloid plaques get created from that cholesterol process.
Okay, so this is interesting for me. No, this is fascinating. I still have a billion more questions, but we're going to have to wrap this up. I know you have to go. I think we need a part 2, but the ApoE4 story, the high cholesterol story, that's me. And so I know that plenty of other women are like that as well. It seems that when you go through menopause, so many women, even though with a healthy diet and lifestyle, we get scared by our doctors saying, oh, you better bring it under your cholesterol levels under 200. And we're trying everything we can. And we're looking for ways to optimize our cholesterol levels. Now you've given us a very interesting piece of information in terms of the optimal levels being a little different than what your cardiologist may tell you or traditional doctor is telling you. And this is just information for all of you guys. I'm not saying that you should do, obviously do your research, your due diligence, and talk to your doctor about your own particular situation. However, what I've picked up from you as well is, okay, so let's try to get out in those optimal ranges between 220 and 250, more or less. So then you mentioned the plasmalogens obviously play a huge role in this and can help us transport our cholesterol and utilize it optimally as well. So I think that you're going to say, well, I think we've talked about exercise, for example, increasing our plasmalogens. I would like to talk about other ways to optimize our plasmalogens. But before we optimize our plasmalogens, we probably have to test them. So how can we test our plasmalogen levels? Because certainly our doctors are not there yet, and hopefully they will be.
We have a large network. So at prodrome.com, you can look for that. There's a large network of doctors that do. And that's what I do. I teach doctors how to interpret lab results. Okay, not from a diagnostic perspective, but from a human health perspective. What are the healthy levels? What are, how do you supplement and nutritionally support someone to get optimal health? And so the blood test looks at that. And I guess the last thing I wanted to tell people was that if you're looking at the generality of health, you have to stop and actually first think, what does the human body actually do? Okay, and we forget about that. We get stuck in the weeds. We get stuck on some little microcosm of human health, and we forget its basic purpose. Okay, the basic purpose of the human body is to release sunlight energy back to the universe. Okay, that's really what it does. Okay, we are a hybrid electric car. Okay, we consume hydrocarbons. Okay, and the hydrocarbons contain energy from the sun. That's what plants do. Plants take the energy from the sun using the chloroplast, and it takes carbon dioxide and water, and it creates glucose. Okay, and then from that and the energy from the sun is stored in that molecule. And then all these other complex things get created from animals and a whole bunch of other things. But basically, that's where hydrocarbons come from. The human body releases that. So we breathe in oxygen, we breathe out carbon dioxide, and you pee out water. Okay, so what we do is carbon dioxide and water, the two things that was used to create the glucose in the first place, we release back in the environment. So we burn it. We are an internal combustion engine. Okay, but it is everywhere. We have trillions and trillions of these internal, like it is, every single cell has thousands of these little mitochondria. Okay, so you think of your Tesla car, for example. Imagine every single piece of paint, every piece of rubber on the tire, every piece of upholstery is the battery. Okay, that's what the human body is like. Okay, there's not a single piece of it, maybe your hair doesn't have it, so, but not a single piece of the human body does not convert energy backwards. And what it does is it stores that energy as a battery. Okay, it charges a battery called the electron transport chain in your mitochondria. And this is and so you're burning up, right? And so this is where all that oxidative stress comes from, that mitochondrial function. So number one priority is that engine of your body. It is the core of every single cell of your body. And that's where part of the exercise comes in. And the nutritional, your B vitamins, your, talk about N-acetylcysteines and your carnitines and that nutritional component, because if that system is working, you don't get oxidative stress. Okay, it's when your engine is smoking. It's like you're following a car on the freeway and there's a bunch of black smoke coming out. That is when an engine isn't burning smoothly. That's what's happening at the biochemical level in your body. And then your body has to deal with all that crap and smoke that's coming out. And that's your inflammation. That's your cardiovascular disease. All those things come from that core component. So that's the one part. Then the physiological structures is membrane structures and the other core components, the cholesterol, it's the plasmalogens, it's the suppleness of your body. Okay, these are the core components of whatever you want to do. Okay, if you want to climb Mount Everest, if you want to go surfing, or you want to watch TV, it doesn't really matter. Whatever, that's what the human body has to perform. And understanding those optimal levels is really the basic stuff. And then once you get the basics of human physiology working, then you can get more fancy. There's people out there that do really good work on peptides. There's other, you can get more fine tuning of your hormone levels. And then you start having a purpose. But it comes down to first understanding what health is and looking for deviations from health. And then not thinking about what does this deviation mean from a disease perspective. It's like, if this is where it's supposed to be, this is where it should be. I don't have to wait for the negative consequence. So we call it prodrome scan blood testing. It looks at these core components of human physiology at this really general, full level. And it's very powerful understanding this general physiological health of an individual from the inside out. And it teaches doctors and it teaches people how to understand what health really is biochemically, how to listen and have a communication with what your body is doing. Because everything that's happening in you, okay, if you're sitting next to your sister and your sister has ovarian cancer and you don't have it, okay, there's a biochemical reason for that. Okay, there's a physiological difference there. Okay, anything that you can visually see or feel, okay, there's a biochemical correlate of that, because that's how we are built and made. And it's just a matter of learning how to communicate that. So that's the blood testing. So prodrome.com, there's doctors for that. And obviously the plasmalogens are a big component. I call it, it's kind of like a Trojan horse in a sense. Let's get your attention on plasmalogens because it is a really big hammer. Like it's really something you don't want to be deficient in. But then while I have your attention, let's fix a few other things while we're at it. Okay, because they're not the only thing in your world to make sure that it's healthy.
So there's this test that we can get on prodrome.com. And you said there's doctors as well there that I guess they would, I'm not sure, do they have to order it or they just interpret it? Can anyone go and buy this and then read it themselves?
We're trying to get more, but we really encourage people to use these functional doctors that have been trained in this and then they understand it, because this communication process is just healthier when you have a partner with you, and you can biohack it yourself to a certain degree. And absolutely, there's that. The blood testing itself, just you can read about it, like the courses are all there, but we don't have a real public version of it, just because it's not about, like, normally when you get a blood test, you say, oh, my cholesterol's high, low, there's a cutoff point. What is my uric acid? People get obsessed with high levels of uric acid, which is another pet peeve of mine, because it's low uric acid that kills you. But it's understanding the level of your biomarkers is not some sort of pop quiz on you, right? It's saying, what does this mean? It's why. And sometimes the same level of a metabolite, okay, can have a different meaning based upon your health situation, right? And so people take a very dangerous situation is to pick one piece of information in isolation of other things and draw big conclusions from it, right? Like you can have a big salary, right? But if you have 10 times the expenses, then it's not a big salary. And you can have a smaller salary and no expenses in your life, and you can have a very healthy financial situation. So just because you have X number of dollars coming in every month doesn't mean that you're financially stable. So the same number can have different meanings. And in one person's life, that could be, wow, I'm awesome. I have extra resources. And another person's life, it could be, man, this is bad. A good example like that is autism, for example, and multiple sclerosis. We measure blood plasmalogens in those people. They'll typically be higher than normal because they have mitochondrial dysfunction. So the high levels of plasmalogens in the blood, because remember, we're not measuring a piece of your brain or a piece of your muscle. Okay, we have to understand what that means. If they're really high, the question is, why are they so high? Like, unless this person is like, super bodybuilder, chances are they have a mitochondrial dysfunction. Whereas a separate person could have low plasmalogens, okay, and we know clearly, well, that's bad news, because we can say the peroxisomal function. So it's not what the biomarker is. The question is why is the biomarker what it is? So it's not what the biomarker is, it's why. And the same thing when people talk about this biological age clock stuff, okay, which is, again, I'm not a big believer in, but that's fine. People can have fun with that. Okay, the question isn't what your clock is. The question is why is your clock the way it is? Okay, and your body, the clock is a representation of you. Okay, you have to learn how to ask the why question, not the what question. And once you understand the why question, so if you're 60 years old and you have a biological clock of 30, the question is why do I have a biological clock of 30? Well, it's because I have a physiology now of a 30-year-old. Okay, because I've trained my body to act and think and believe it's a 30-year-old, and it has genetically adapted to this purpose I've given my body. Okay, the clock does not make me 30. My physiology of 30 makes my clock look like I'm 30. The clock is just the gas gauge on your car panel here. Okay, if I take that gauge and if I just move it from E to F, it doesn't miraculously put gas in my tank. Okay, so don't confuse a biomarker or a measure with the actual reality behind it. Okay, and so often, and that's why, it's not that complicated. It really isn't. The educational courses are there, but in the real world, when you deal with thousands and thousands of people, a lot of people just want some short answer to something. And
yeah, that's what we want. Your website is chock-a-block full of information. So if you're a health practitioner and that's your world, you've got these great courses and you can understand it. If you're just want to know your biomarkers and your plasmalogen levels and understand them and how to get them optimized, then that's when you'd go through one of your already doctors that are already presented there. Just a quick question about so you have a kit that we can test our plasmalogens, but it sounds like you just said that there's so many other biomarkers that this test kit tests, or did I get that?
Oh yeah, it measures your lipid function, your plasmalogen function, it measures your mitochondrial function, measures your methyltransferase system, your cholesterol regulation system, your kidney function, your
Oh, so this is like a full-on, yeah, get it like check.
It's a checkup. It's a hand-selected subset of molecules that give you a very clear picture overall. Now, educational wise, if you want to learn more about the cholesterol, okay, that is available, okay, on the website. There's a advanced lab test interpretation course, so you can learn the data, what cholesterol really means, the risk factors of cholesterol. You can learn about uric acid. You can learn about plasmalogens and phosphatidylcholine levels, for example. You can learn about these things. And a lot of these blood tests, a lot of this information is going to be even in your simple little, your metabolic panel that you get, and you can look at that yourself and start looking, and you can start interpreting some of that stuff. What the blood test, the prodrome scan does, it puts it it organizes it in such a way that you can see, okay? Because part of it is like taking an empty house and putting furniture in it so you can actually see what it looks like. It's like, okay, how you organize things is the way the brain can think about things. Like if I have a whole bunch of things in isolated, disconnected spaces, then you can't understand the patterns. You can't interpret what's going on. And so the prodrome scan has a bunch of specialty blood markers, like the plasmalogens. There's some gastrointestinal tract acids your gut microbiome make that we measure. We measure sphingomyelins and ceramides that are very indicative of membrane health. Fatty acid elongation, which is a critical biomarker for ovarian and breast cancer, that's all put in there. And so there's a number of specialty components of it. And then there's several markers that we've had for forever. They're very valuable markers. Like they're still your fasting triglycerides and your cholesterol, and these are still credibly, we've been measuring them for 1,000 years, it feels like, but they still have credible value. We don't use them enough. People scuff off of those things, but there's certain little rules that really deliver big benefits to you. Like I was mentioning earlier, getting your triglycerides under 100. If you want to lose weight, these kind of things, like this stuff is there.
All right, I want to get a hold of this test. I wish I had it before, and so we could discuss it. It could explain. It's just you take a blood test. Do you draw with your finger? Do you go to a doctor?
No, it's a regular venous blood. It's a classic red top tube. And the other thing we do is we biobank all your blood samples. That's it. My other pet peeve when you go to a traditional blood testing, they take your blood, which is pretty serious, right? They come in, they're going to stick a needle in you. They're going to get a vial of blood. They're going to ship it off, and then they're going to throw it in the garbage when they're done with it. Like, what the hell is that about? So we actually biobank our blood work, okay? And so it's like, it's like taking a computer restore point, right? You say, here's my blood work. It's there for the next 50 years. So I can go back to my blood sample when I was super healthy, okay? And I can look at what's happened before and after. I can go back and reanalyze the blood work. So we biobank these blood samples for everybody for their lifetime.
Is that an extra cost? Is that?
Yeah, right now we just do it because it doesn't. Yeah.
Well, on your website as well, I was looking at some of the videos of how you are testing. If anybody wants to get really, this is a full-on lab, and you can see how you're banking them, how you're testing them, and you do a very good job of creating these videos for us to understand better. So I wanted to get so I know you have to go, and I keep hanging on to you, but I'm glad we have the possibility to test not only I thought it was just the plasmalogens, but it has a whole other, we can test so many other things, go through doctors, get it interpreted. And then what if we do find our I don't know if you have time to talk about the ways to increase your plasmalogen profile. Do you want to do that in another?
Well, I can do it in 10 seconds. And so, yeah, I guess that's a good point. So so you get low plasmalogen. So what do you do about it? So I'm not in the world of saying, hey, it sucks to be you. Sorry, can't help you. No. So the whole point of the blood testing work is that this is you. This is your personal, your biomarkers are you. Every single thing we measure on the prodrome scan, you have control over, and you can adjust them. Now, plasmalogen precursors been a challenge, and we haven't had them available for the last 100 years in human health. And it's only been the last couple of years that we have them. It's because I designed plasmalogen precursors that are basically designed using the same structure that's in human breast milk. They're called plasmalogen precursors. And we have two types. We have an omega-9 that's for the myelin, that's used for autism and multiple sclerosis and these rare diseases of demyelinating children. And then we have the omega-3, which is called prodrome neuro. And it has the DHA on it, and it's designed for increased mental function. It improves cognition statistically in clinical trials. Like, it's been tested, heavily clinical tested. And so those are precursors. They're designed to go into your cells and let your cells make the final molecule. Okay, and that's and they're designed to be bioavailable. They're 100% vegan, other than the gelatin capsule, but that's changing. But the oils themselves are pure oil. There's no additives, that kind of stuff. So we make that, and that can be used to restore your plasmalogen levels and maintain youthful levels. So
And
you can measure your blood test.
how long would that take before you retest and see if it worked?
Well, it works in 24 hours. So you can take, if you take enough of it, but over time it has to fill up. So typically I get people to retest in about 3 months, because we don't want to just adjust the biomarker instantly. We want, because your body then kind of gets back to a healthy state. So usually the first prodrome scan, we take a look at, is there any, boogeyman under the bed that you had no idea was there? Like, I'm super healthy, I'm feeling great. And but you didn't even know, you've been driving, a race car with a bald tire, and you didn't even know it. Oh my God, I could have crashed and I didn't even know it. And so that part one is just saying, is there anything that just not what you thought was there, that you fix it right away? And those things happen a lot, like phospholipid levels. People talk about PCs. Like, take about Steve Jobs. Anyone in your world that ever got pancreatic cancer and died, they had a phospholipid deficiency, period, full stop. Okay, we measure that kind of stuff. And so the first thing is to get that understand that universe a little bit. Is there any, what are the big crises that we want to avoid? Fix those things. And then this, about 3 months later, we can do a fine tuning. And then after that, it's once a year. The other part, like for my, I'm mentioning a whole bunch of my pet peeves, but it's, life is to be lived, right? You don't want to be obsessing over your health every single day. And we obsess over health because we're scared. Okay, we're scared that we're missing something. And so, am I doing glucose monitoring? I'm doing my steps, I'm doing this, I'm doing that. And all of a sudden that starts, and rather than helping your life, it becomes an obsession, and it takes away from your life. And so the goal of what we're trying to accomplish here is understand what your healthy physiology should be. And then you shouldn't have to be obsessed about it. And once you've found a system in your world, a lifestyle and a diet and a supplement program that's got your body in its healthy state, go live your life. Okay, do the things that you need to do. Check up every now and then, but don't have this become an obsession and drag, because that's part of the process here. It's this fear of the unknown, and it drives us all crazy. Okay, we're saying, am I looking for the right thing? What's going to happen tomorrow? And so we want to get, we can't solve every single problem on Earth, but the big ones we can kind of get, like physiology wise, we know what the human body should look like. Okay, and some more advanced technology will be coming down the pipeline is advanced MRIs, for example, measuring the brain and understanding what it should look like, how it should function. Okay, people should expect their body to work. You expect your heart to work, expect your lungs to work, expect your muscles to work. Okay, they're there to work. They're designed to work. If they're not working, you just haven't, done the right thing to put them back on track. Your body is designed to work, and it should work for as long as you maintain it.
Thank you so much. So well said. It's inspiring. I would love to share where people can find more about you. That's on prodrome.com, also drgoodnow.com, and I will have links to that in the show notes. Instagram as well, you're Dr. Dayan Goodenowe, and I'll also provide your email. And we'll have a discount code. We haven't sorted that out, but you will just look out for that in the show notes or in the beginning of this podcast. And we will have some discounts for if you want to try to get testing and any other things that you find on the website. Is there any, or are there any last words for a woman going through menopause?
Biggest thing is create a purpose in your life. You have to create a new purpose. You have to have a reason to live. You have to have a reason to be healthy. That's the biggest challenge. People start losing their sense of self-worth. They they've associated themselves with a youthful childbearing phenotype, and they feel that they're no longer a woman again because they don't have these same things. And that's just bullshit. Like, you have to create purpose, and you have to create a new, you have a new life, and it's going to be longer than your old life. Okay. And so plan ahead for it. Like, that's the bottom line. Because if you can feel it and think it, everything in your world, everything in your universe will come towards that. Okay. And, we talk about these things in aging, right? We talk about people going out for social activities and how it benefits. Well, they don't really do anything. But what they do is they force someone to get up in the morning and put their clothes on and do their hair and clean up and all these things. And so all of a sudden now they're going out and they're having a decent meal. They're not eating dry toast or something like that. And so the purpose in your life, you create a purpose to get up and do something. And then everything around your world gets drug in with it. Okay. And if you create a positive purpose, make one up if you have to. Okay. And then everything else will follow through on that. Okay. And that's what people forget. They think, oh, great, I can retire, I can sit and do nothing. Well, you're going to die. Okay. Because you're basically telling your body, you're telling your brain, you're telling your body, you're done. There's no work, I'm just putting in time until it just all falls apart. And so if you don't want it all to just fall apart, you have to have a purpose. And then your world will follow that purpose. And if your purpose is ended because your kids are grown and you have to make a new one. Just fundamentally, it is never ever retire. If you can retire from a job, but you can't retire from life. Right? You have to have a purpose. That's the number one thing people forget. They think, oh, I'm done. And this portrait of Dorian Gray doesn't work. Like, that does not happen. Okay, like it's anyway. So that's my last little spiel. I think that's the biggest. A lot of it's psychological, because then people forget that drags everything. It drags it helps you choose your relationships. It helps you get rid of toxic people in your world. It's creating an environment that is conducive to these healthy situations. Okay, it's rehab. It's really rehab. I tell people we are addicted to dying. Okay, getting old is like being a heroin addict. Okay, we know exactly there's not a single heroin addict out there that doesn't know heroin's bad for them. Right? They know it's bad for them. No one say, this is great stuff. Look at me. Like, I can't wait to get my new healthy dose of heroin. Every drug addict knows it's bad for them, right? But they just can't stop doing bad stuff that they know are bad for them. Well, we know what's bad for us. Okay. So all these bad things that we do for aging. Okay. It's not like it's oh, I didn't know that was bad for us. Well, yeah, we know it's bad for us, but we can't stop doing it. Right. So we're addicted to dying. And so if you don't want to die, you have to rehab yourself from the patterns that create death. So it's really aging rehab is where I look at that. Anyways, that's my spiel. As you can tell, I'm very passionate about this stuff. I think it's fun. And you know what? At the end, you really, if it doesn't work, at least you tried and you had fun doing it. Right? Like seriously, like it's, you got to do something. So you might as well have fun doing it. Right? And so
Yeah.
what's the downside? Really? Like, really, what is the downside of living healthy and being positive and creating a purpose in life and trying to find worth in what you do in this world? Like, what's the downside? So pick something to be fun at and good at.
Excellent. I love that. Yeah, find your purpose in life. It is life-changing. Thank you so much, Dr. Goodenowe, for your words of wisdom and explaining all these plasmalogens and our cholesterol and helping us optimize. I really, really appreciate it. I still have a lot of questions, so I really hope to have you on again, and have a good day.
Sure.
You're in the US, and everyone who's listening, good day, good morning, good night, wherever you are. Thank you.
Thank you so much, Zora.